right, welcome to the talk Good for Karma, Configuration at Runtime. I'm happy that this room is so very filled. I'm also a bit anxious, all right. So during the talk you can direct all the questions to me, so either in English or in German, but that's the only two languages that I can provide to you. So what am I presenting today? This is the small agenda for the next 45 minutes. It's about the everyday configuration changes that we all experience in our daily operations developer life. And I also brought 3 tools that I want to show you, Archaius, etcd, and Togglz, and also have a small demo how this can work out. And at the end, after we've seen all these tools, well, I try to tackle this question, is it better with configuration at runtime, yes or no? All right, a short break for some commercials. My employer is the MSG Systems, founded in 1980, some time ago. Based mostly in Germany, 14 cities, but also 12 countries worldwide. Some turnover, lots of nice colleagues that do great projects. And we are one of the sponsors of JUnit Lambda, well, the medium sponsors in the end. I myself, I'm an IT consultant, basically working in Java world for several years, done also other programming languages like PL SQL, that's very different. I've been working in consumer finance for about 7 years, 3.5 years done in online banking with the German Direct Bank, married, 2 kids, yeah, and a hobby, at least a bit of a hobby. Looking for geocaches wherever I come around and maybe have a conference. All right, so end of the break, go back to the agenda. So about these everyday configuration changes, how do they look like? There are people coming around and saying, oh, there's a database, it just moved, it has a new IP address. Maybe we can change this configuration file for this online registration, so all the online registrations go to the new database. And we say, fine, no problem, I changed the configuration file, we just need to reboot the application during the next night, and that will be fine. Well, am I then a hero that I stand up in the middle of the night and push a button to reboot an application? I don't want to be that hero. I have a family, and even the IT operation guys have families as well. So nobody should stand up in the middle of the night just to enable this change of a configuration variable. And even the customers, they will get these nice signs about, well, the service might not be available due to a reconfiguration. This is something we want to avoid. We don't want to restart our application. Some people might be as lucky as that they have a continuous deployment pipeline where they can deploy as often as they want. But I've seen a lot of people, including some of the systems I support, they're not capable of doing that. So let's find another way for doing that. Other daily, changes are, marketing comes around and asks, well, there's a new feature in the application. Can we just switch it on? We want to activate it. Yeah, well, we need to do a deployment, and once the deployment is done, the feature is active. No problem. But then, should you do something like this on a Friday afternoon? With a new feature, it might even be working as designed, but the users might not understand how it should work, and they start phoning up your help desk. And, well, this is really deadly if you roll out something like this to all the world. And what you could do would then be a fallback that would need a redeployment or rollback deployment, like on the Saturday night, somebody is very sleepy. You don't want to do that. So that's poisonous. So let's find something better for this. We want to do these configuration changes, well, basically at runtime. We don't want to have a maintenance window. We don't have want to save this time and want to have no hassles. And I present 3 groups and also 3 tools for these 3 groups. We want to change application parameters at runtime. It might be a target address, like a really technical configuration where this database resides with an IP address, a URL. It might be a folder where we store the output of our application in a nightly batch. It might be timeouts or business parameters for an interface. All of that we want to change at runtime. The second area is I might have not only a single instance, but multiple instances. and I want to store the configuration for all these instances in a central place, in a central, highly available place, hopefully. Or there might be different applications who want to access the same configuration parameters, so that even if different teams develop this application, they use the same configuration metadata there. And if I store their configuration data, I can also try to store their information about if a service is up or not up, and do something like service discovery, where I can look up the URLs that that service is currently running on. And well, about activating new features, we don't want to activate features by deploying a new version. We want to be very, very specific who sees a new version. We want to pick special users that might be our power users that are piloting that feature, or we want to select a group of users. We want to give this feature only to a small percentage of users. Or we want to even have a timed application. So when the press mailing goes out from our marketing department, only at that specific point in time this feature is going to be activated. All right, so why Karma? So at least the idea is behind that we as developers, we choose how we develop our software in terms of configurability. And this is one of these actions that has consequences for ourselves usually. So we are responsible for what we do. These configuration changes, they should only do the configuration changes. They should not make somebody get up in the middle of the night. They don't need to enforce an application restart. They should only do what they're intended to do, the configuration change. And we know that configurations change all the time. That's why we do a configuration in the very end. We want to be kind to our customers. We want to be kind to our IT operations people. We don't want to have maintenance windows, and we don't want to be heroes. Neither we nor the IT operations. All right, so let's look at the very first tool here. So the first tool being Archaius. So what's that? Archaius is a small piece of the, Netflix stack, I would call it. And it manages the access to parameters by Java clients. So Archaius the name is derived from a chameleon, a small, nice, greeny little creature. But what it can do as a software component, it can load configuration data. It can load it from property files that are stored on disk. It can load them from URLs that are remotely. You can retrieve it from a database, from a normal SQL database. There are adapters for that ready to use. The second thing it can do, it can cascade these configurations. So if I have multiple configurations, like a standard configuration, a configuration that is specific to an environment, and then maybe a configuration that is specific for a single server, it can stack them all together. They layers them, and I will get the most specific configuration entry for this configuration variable. So I can override them as often as I need it on any environment. And this makes managing environments very, very easy. It allows me also a type-safe access to the current value. We will see a Java example in a minute. So it's not handling string and property names all the time and converting these strings to some business object, but then we have really type-safe access to the current value. And the fourth thing that is, I think, the very cool thing, all these first three things I've seen them implemented in many, many projects by hand again and over again. But the fourth thing is really cool. I want to get a callback in my application once a value changes. And this gives you the real possibility to do the last 5% of runtime configuration when it comes, for example, to resizing thread pools or something like this. This is really cool. So what do I need to do when I run this in a Java environment? I add some more command line arguments to my Java process. For example, I specify the environment. This should be now the test environment that I run my application in. And during my Java startup, I load some cascaded properties from resources, say, okay, this is the database resource or description being basically a property file. And I have a standard database. Now it's named standarddb in a database.properties file. And I have an environment-specific properties file that is then referencing the same name that I passed as a command line. And this is then, well, layering on top of the original properties file. And whenever I now ask for the database URL, I will get in the test environment the test database, and in any other case the standard DB. And so I can have also multiple environment-specific configuration files, and depending on the environment, the right configuration is pulled. So this was the layering. But then, what about this configuration at runtime thing? I tell Archaius where to look for these configuration files, being either placed on disk, or I can also put a URL there where it fetches this configuration. And I tell it how often it should fetch this value. In this example, I have overwritten the default values with once per second. So once per second, Archaius will read the contents of the file and check if they have changed. And also every second will pull a remote URL and find out if anything has changed on this URL. And yeah, this could be then a configuration file, like a properties file, like any other, where I have a database application timeout with 1000 milliseconds in there. And to this value, I have now a type safe access using Archaius. So I can use a dynamic property factory and get an instance of an int out of that configuration that I specified, and say, okay, I have a property name that's referenced from the file and the default value 10, and this is then overwritten by the real entry in the file. But if nothing is specified, it would take the default value. So I now have this timeout property. And every time I want to get access to this timeout property, I want to get the value. Well, there's a getter for that, so I get the value. And this will always return the most up-to-date value that is stored, well, that has been retrieved by the cyclic pulling from that file. So it will always be the up-to-date value. I can pass this object around, and it's always safe to call with the latest value. And then there's also this callback that I talked about earlier. For each property that I defined here, I can add a callback to trigger whatever logic is necessary in my application to reconfigure well, the application parts that need to be reconfigured when this configuration value changes. All right, so that was Archaius. So the good thing about this, it can be basically built in any application. You don't need to rebuild your application. I think in most, even legacy applications, you could try to integrate that. And the configurations, if you're rolling out your configurations today using any kind of Chef, Puppet, Ansible, or Salt, you can roll out your configuration as you do today, but your application doesn't need to have a restart. You have different storage backends. You can store them as files. You can store them in a database, in a SQL database if you want to. And you can also combine multiple backends. You can have some local configuration that is then overwritten by a database. So you can, if you need that, get a real complex configuration there. Hopefully it will, yeah. But again, if it's complicated, humans also tend to make mistakes, so better keep it simple. So I have this hierarchical structures that simplifies my setup. So I need to have only the environment-specific override of my standard configuration. In this library, Archaius is a very proven library based on Apache Commons configuration. So that's an API that has been around for quite some time. And it's, well, quite easy to use and to extend. Also, if you want to write your own backend to store maybe this information from Archaius in a different database. And as I said, these callbacks are really cool to do the reconfiguration of the last 5% that you would otherwise not be able to do without these callbacks. And I wouldn't reprogram that myself. All the rest might be done in the project again and again, but not the callbacks. I think that I've never seen that being manually implemented in an existing project. So the thing that might get a bit complicated, the more configuration stores you have, the more difficult it's going to be to change them. So you have a database and several files. You might maybe think about in what order you want to change them, first the files, then the database, or vice versa. Yeah, that might be a bit challenging, so keep it simple. If you think that's something you might need for your project, you should also maybe look a bit left and right. There's Apache Delta Spike that also offers some runtime configuration in a Java EE context, a little bit more. There's an upcoming Apache Commons configuration 2.0 that's currently being developed and a matching Archaius 2.0 version. There's also another Apache project, Apache Tamaya, that is tackling the task of runtime configuration and to solve that once for all. So that's, but still, this is going to be developed. I don't think they have a production release ready yet. The last time I looked at it. All right. So we now have our application, our Java application. It can now pick up configuration at runtime. Let's have a look how this looks. So I have a sample application here. I have this dynamic int property, app timeout, and once I go to my file and change something, yeah, the callback is being called basically 1 second after the file has been changed, and it works. No fancy graphics here. Well, it's configuration anyway. All right, let's look at etcd. So that's how we can orchestrate several instances of our own application or coordinate several other applications together. So what's etcd? Well, it can be used for configuration of for service discovery. It's quite easy to use. It has an HTTP and REST interface that can be, well, that is then called with JSON. It's reliable and consistent. You can set up a small cluster of like 3 or 5 instances of etcd that are then highly available and consistent. It's secure, as you can use SSL client certificates to secure the connections to etcd. And it's fast in a way that it accepts several thousand write operations per second. So that's really nice. And as it has a REST interface, it has something like a get to read values, put to write values. You can delete them. There's a compare and swap operation. You can also do something like a long poll here, so that the call only returns when a value changes in etcd. And there's something also like a time to live. Like you can write something in it to etcd, and if it's not being refreshed, this entry will automatically be deleted by etcd. So that comes in very helpful in cloud environments when you have a service that's writing some new information into etcd, and this information should only be valid as long as this service is running and updating this value again and again. And once the service dies, this information is then automatically removed by etcd after the time to live has expired. Well, as it has a REST interface, you can use it with curl. I can use put to write something in this key store. Basically, it's a hierarchic key store with an URL. So under foo service, I now add an entry for container 1 that has a URL localhost colon and a port number. If I want to read it, I use the same URL but using the get request. And if I want to be notified once something changes below that foo service URL, I put await equals true at the end as a query parameter. and a recursive to be notified if anything changes below foo service. So that's the REST interface of etcd. So yeah, now I have all these values stored in etcd, but then, as we've seen before, my application is still using configuration files. How can I get these two together? And then there's another helper tool called convd that will update my configuration file when it sees that the relevant keys in etcd changed. A small example could be that we have a load balancer in front, NGINX, that now has 2 nodes that it balances all the requests coming into. Now we start up a 3rd node that should also get some traffic. This node writes its URL using REST to etcd. Convd is being notified by that change, and then it rewrites the configuration for NGINX, reloads the configuration for NGINX, and then NGINX knows, all right, I need to balance the nodes over 3 nodes. All right, so how does that look on a command line or a configuration file level? And you provide a service description here, like a template, and a template for a configuration file that look like this. Basically, that's the information convd needs to find out where to find the template, where to write the configuration to, how to restart the service, and what keys to watch in etcd. And well, then you also need the template. And this way, you can rewrite configuration files based on changes that happen in etcd. But we'll be Java programmers, right? So time for some more Java code. So there's a German's Java client that is wrapping all etcd methods that there are, covering them for 100%. And it's implemented on top of netty, so it's fully asynchronous, non-blocking I/O. So anybody who was maybe a bit shivering and has had long polling for changes on a URL on etcd, this is all then wrapped up with netty, and you don't block any threads for that. So the same call that we've seen with curl in the beginning, I can write now in plain Java code as part of my application. etcd.put with the URL, with the value, and send that. And I can also then do this long poll that we've seen before with the wait query parameter. So in this case, I receive a promise, and on this promise, I then can add a listener to be notified once something changes in etcd. Yeah. So that's the Java API, very nice Java API for etcd. So the pros and cons. Well, the pros is it's really easy to use. It's a simple installation. It's a Go binary. It's even easier to install in Java. So it's really an executable that you can download for Windows, for Linux, deploy it, start it up. Just copy the single binary to the directory where you want it, specify a configuration directory, and there you go. It offers transport security with SSL, and the changes are published to all clients really immediately if they're using this long poll mechanism. This key value structure is very generic. I can store in there configuration values. I can store in there like service discovery information, like host names and port numbers. So that might be an advantage or a disadvantage. So any idea that you have about that, you can also program something like leader election on top of that. So that's really nice. So that receives how to use that. What you might be missing in an enterprise environment is, with etcd, is that you don't have access controls on client level. So basically the key space, once the client has authenticated with a client SSL certificate, is, well, flat. Every client that has access can read everything and write everything. It's a young open source project. on the other hand, is part of CoreOS, being one of the platforms to run Docker containers in private clouds. So it's proven to some extent. That's really cool. There are some other open source projects I want to name here that build on top of etcd. There's, for example, Vulkan, an HTTP load balancer that stores its configuration directly in etcd, so you don't need to have this detour by confd. There's SkyDNS. If you have service information stored in etcd that you want to distribute using DNS, that you have like resolving, that you have host names that should resolve to the host where the service is currently running, you can use that SkyDNS to do that. It's basically an alternative to Zookeeper. So if somebody's not want to run any Go code anywhere, there's still Apache Zookeeper for full Java implementation that is also very well mature. You can also. When I looked around redirection, I was very surprised that you can do something like that also with Hazelcast, but that would only work within one application that has several instances. You won't be able to span Hazelcast to really other application languages. There's something like Eureka when you're looking at full service discovery there, and if you're looking at some more enterprisey features, you might also want to look at HashiCorp's console for service discovery and configuration store. If anybody has some more questions about console, I have some nice examples for that as well. All these URLs will be at the end of the slides as well as a summary, and also the slides will going to be on Twitter once this talk is over. All right, so we now have Archaius that is doing the runtime configuration for my application. I have etcd as a central configuration store, and then, these two could go together, right? I could use etcd as a backend for my Archaius. And the good news is Archaius 2.0 has a backend that is already included for etcd. So these tools go very well together. If you not want to wait until this 2.0 is ready, you can write then, your own implementation and own backend. I've done it in a sample project. So basically, when you put something, let's see if I get this here right. So basically, when you're, for example, writing new URLs to your etcd using curl, your service will then automatically be notified that there are changes in etcd. So that works like the local file as well, because it's a backend that I plugged into Archaius, and it's the same as a file. So they go very well together. But still, the third problem is unsolved. What about these feature toggles? So we want to activate features on demand when we want them to be live, independent of the deployments. The scenarios are, there are not yet released features. They are currently being tested. They should only be active in the test environment, but they should never be live, active in the production environment. The tool Togglz delivers me a web front end, we will see in a minute, where I can activate and deactivate the features at runtime. And I can also add rules to show the new functionality to some users or all users or at a given time. And this is giving me the switchboard. And it's also included in the logo of the Togglz library. So that's my switchboard. So that's an optional component of Togglz that you can use in a Java EE environment very, very easily. So I have two features defined in my application, and I can use this configuration button and either enable or disable that feature, use a gradual rollout and say, okay, I'm safe to go from 40% of all users to 50% of all users. And this is then immediately active. It uses in the background a consistent hashing of usernames. So the moment you change that percent, that ensures that a user that has seen this feature will see it also the next time when it comes to the site. And when you change this percentage from 40% to 50%, that 10 additional percentage of the users will see that feature. I can also do that by IP address. So if I have a special company that I can identify by IP address, I can open that feature only for that IP address or only on a special server, on a special date, on users by name, users by role. And there's the one scary bit. You can put in JavaScript here to have your own rules. For me, code should be put in a repository and not in a paste-in field in the browser. So, but it's there. Your choice. But then you can also choose to deploy. Yeah. So that's a front end where you can configure that really at runtime. That's really nice. So how do I use these feature toggles in the code? Yeah, you start out defining enums for one enum for each feature being either on or off. And then you query them in the code. So this is the enum. Feature 1, skipped feature 2 for to save some space here. And I put a label on that describing the feature. And out of that enum, the web page is generated automatically on the fly when I use it. So there's no layouting, it's always consistent with the feature toggle that I have in my code. I can also group them, so I have different tabs. So that's all included in there. And how do I use an enum? With this is active, so I have an if in my code. It's quite simple. Looking a bit oldish, maybe, but on the other hand, this gives me the power to really use my IDE to look up the places where I use these feature toggles in my code. Just go into your IDE, find the usages, and there they are. And I can do the new exciting stuff once this feature is enabled, or I can switch between the old implementation and the new implementation here. Yeah, that's how these feature toggles can work in Java. So, again, pros and cons for feature toggles. Well, feature toggles have been around for quite some time, and I believe, they're well understood. There are lots of implementations for different programming languages. There are also several implementations for the Java language that you can choose from. Feature toggles, they do increase the complexity of your application, at least for your tests, if not for the rest of the application. And, good housekeeping tells you that you should remove that feature toggles once this feature has been rolled out. I read some people writing, okay, you should keep them in so you can use it to switch off this feature when maybe this external vendor is not responding correctly, so you have a fallback that you can use feature toggles for fallback. But to my opinion, you shouldn't use that for that. There are other libraries like Hystrix that do things that much better than feature toggles can do that. So feature toggles should be used for new features. They shouldn't be used for business strategy, switching things on and off. So there's some additional effort, but then it might still be worth the effort if you have frequent releases. If you're aiming at continuous delivery, you don't want to have the situation where uncompleted features would then otherwise block the completed features. So you can imagine you're doing a sprint. At the end of the sprint, 2 out of 3 user stories are accepted, and then the feature toggles of these 2 user stories are then activated in production, so they are live. And for the one that is not being accepted at the end of the sprint, the feature toggle is not being activated. So you get all the return on investment for these 2 user stories that are done, and these 2 user stories are not blocked by the 1 user story that is not done. Another very interesting aspect is, well, the second thing is, well, you could use a feature branch, right? But feature branches, the longer they run, the more painful they are to merge them back. If you're using Git, you might do something like a rebase now and then, but even that, yeah. So if you say, I don't want to use that much of feature branches anymore, at least not so very long-running feature branches anymore, then feature toggles might be worth the effort for you. And well, the third thing that is, well, might be almost the best, well, might also be very interesting for your business, when you're now able to do a gradual, very early rollout to maybe 10% of the users with a partially completed feature. You can get feedback that can steer the development of the feature and make it really production ready. Or you might find out by doing an A/B test to just a small number of users, like you implement the feature only for one browser, you implement it for Chrome, try it out for all the users that are working with Chrome, and you will find out this feature doesn't work as expected. It doesn't increase my conversion rate. It doesn't increase my turnover. You don't implement it. You cut off, you spend like 20% of the money to implement it for Chrome. You find out it doesn't work, and you save the rest of the money, the 80%, by not implementing it for Firefox and Internet Explorer and everything else. So this early feedback might also be worth the additional effort. Right. So now time to answer the question. You might have guessed. My answer to that is, well, yes, configuration at runtime is better than without doing it. So having access to a change in configuration, like you don't need to restart your application server, even if that's now faster today than it has been some years ago. It helps you even when you're developing your application. It's really minimal effort to add runtime configuration to your Java application, and it gives you great flexibility for a production environment. Central configuration store is great when you want to share configuration data across applications. You can also use a service discovery, and if you want to go in the direction of cloud scenarios of services scaling automatically, that's where your central configuration stores helps you. And well, feature toggles, as I said, it simplifies development and deployment. They give you benefits there, and the benefit that's also there for the business is then the early feedback from production that helps you either to find out if that feature gives you the business benefit that has been intended, or it helps you also to improve the feature. So with the feedback to make it more self-explaining, to have less calls in your service center when people don't understand how to use that feature. All right. As we are at the end, as we now answer this question, we are at the end of the presentation. As promised, a list of all the tools that I've shown here today, all the configuration, runtime configuration tools. There are also some links to console on this page, and all the tools that we've seen here. All right, thank you very much.